Hello, good morning everyone. Today in this lecture I am going to discuss about the transmission media. So first of all, what is transmission medium? A transmission medium can be broadly defined as anything that can carry information from a source to a destination. What does this mean? For example, the transmission medium for two people having a dinner conversation is the air. The air can also be used to convey the message in a smoke signal or semaphore. For a written message, the transmission medium might be a mail carrier, a truck, or an aeroplane. So in this way, we can understand the concept of a transmission medium. But here we are talking about the data communication. In data communication, the definition of the information and the transmission medium is more specific. The transmission medium here is usually free space, metallic cable, or fiber optic cable. In these days, fiber optic cables are very much used. The information is usually a signal that is the result of a conversion of data from another form. So the use of long distance communication using these electrical signals started with the invention of the telegraph by Morse in the 19th century. Communication by telegraph was slow and dependent on a metallic medium. So in telecommunications, transmission media can be divided into two broad categories: guided and unguided media. So here we use electromagnetic energy, a combination of electric and magnetic fields vibrating in relation to each other, including power, radio waves, infrared light, visible light, ultraviolet light, and X rays, gamma rays, and cosmic rays. And each of these rays constitutes a portion of the electromagnetic signals. Okay, so transmission media is divided into two categories: guided and unguided. We can say guided media is also known as wired medium, and unguided media is also known as wireless medium. So this is the electromagnetic spectrum. Here it is shown in this diagram from 0 to 3 kilohertz. In this range, the electromagnetic waves are known as power wise. From 3 kilohertz to 300 gigahertz, this range is known as radio waves, microwaves, and satellite waves. From 300 gigahertz to 430 terahertz is known as infrared lights. 430 to 750 terahertz is visible light, and above that ultraviolet lights and X-rays, gamma rays, and cosmic rays. In this way, this electromagnetic spectrum is divided. So further, transmission media is divided into guided and unguided media. So what do you mean by guided media? Guided media, which are those that provide a conduit from one device to another. This includes twisted pair cable, and second one is coaxial cable, and third one is fiber optic cable. A signal traveling along any of these media is directed and contained by the physical limits of the medium. Twisted pair and coaxial cables use metallic or copper conductors that accept and transport the signals in the form of electric current. But in case of optical fiber cable, it is a cable that accepts and transports signals in the form of light. So what is the difference here is twisted pair cable and coaxial cable. These two cables accept and transport which type of signals? Accept signals in which form the signals travel through the wire? Electric current. But in case of optical fiber, it accepts and transports signals in the form of light. Fiber optic cable works on the principle of total internal reflection. So one by one we will see. This is twisted pair cable. Twisted pair cable. Why it is known as twisted pair cable? Because the cables are twisted in this way. Here it is shown in the diagram. A twisted pair consists of two conductors, and normally these conductors are made of copper and each with its own plastic insulation twisted together. As it is shown in the diagram, one of the wires is used to carry signals to the receiver. Out of these two wires, one of the wires is used to carry signals to the receiver, and the other is used only as a ground reference. The receiver uses the difference between the two. In addition to the signal sent by the sender on one of the wires, noise and crosstalk may affect both wires and create unwanted signals. But if the two wires are parallel, the effect of these unwanted signals is not the same in the both wires because they are different. They are at different locations and relative to that noise source or crosstalk source. For example, one is closer and the other is farther. So this results in a difference at the receiver. By twisting the pairs, by twisting the cables, a balance is maintained. For example, suppose in one twist, one wire is closer to the noise source and the other is farther. But in the next twist, the reverse is true. The twisting makes it probable that both wires are equally affected by external influences, by external sources such as noise source or any crosstalk source. This means that the receiver, which calculates the difference between the two, receives no unwanted signals. So in this case, the unwanted signals are mostly cancelled out. So using this concept, we can say that the number of twists per unit of length has some effect on the quality of the cable. We can say here it is shown that one outer insulator or PVC and the inner copper conductors, and this is the solid copper conductors. Okay. So in this diagram it is shown that the effect of noise on parallel lines. If there are two parallel lines, as we have discussed in the previous slide, if there are two parallel wires and there is noise source, so the effect of these noise source on the two wires is different. But if the receiver receives the difference between two, so for example, if the upper wire has noise effect 16 units, and the wire which is below has noise effect 12 units. What the receiver will receive? The difference between two, that is 4 units. So there will be the effect of the noise in this type of parallel lines arrangement. Next, this noise effect on twisted pair lines. Here the lines are twisted, the cables are twisted, there is sender and receiver. So the effect of noise source on these wires, if one blue and one black, sometimes at one time the effect of noise source on the blue wire is more, but at another point of time, the effect of that noise source on the same blue line is less. So this creates the difference 0 at the receiver's end. If the difference is 0, then there will be no effect of the noise source on the original data or signal which is received by the receiver. There are two types of twisted pair cables: unshielded twisted pair cables and shielded twisted pair cable. So first we are going to see unshielded twisted pair cable. So in this unshielded twisted pair cables, there are so many twisted pair cables inside. Here in this diagram there are 5 twisted pairs, and these cables are covered by some plastic cover. There is no metallic shield on the outer line. Okay. So the most common twisted pair cable used in communication is referred to as unshielded twisted pair cable. So IBM company has also produced a version of twisted pair cables for its use called shielded twisted pair cables also. So shielded twisted pair cables has a metallic foil braided mesh covering the encases each pair of insulated conductors. Although metal casing, when we use metal casing, this improves the quality of cable by preventing the penetration of noise or crosstalk. It is bulkier and more expensive. Okay. These are the connectors, unshielded twisted pair cable connectors. There are 3 types of connectors: 4 conductor, 6 conductor connectors and 8 conductor connectors, and these are used on the basis of the as per the requirements. And this is known as RJ45 connectors. Registered jack 45 connectors are used for the connecting cables. This diagram shows the shielded twisted pair cables. In this, the inner conductor copper, and after that it is covered by some insulator. There are so many pairs, and after that it is covered by some metal shield, and above all it is covered by some plastic cover. So this is shielded twisted pair cable. So after this shielded twisted pair cable, what is the main difference between shielded and unshielded twisted pair cable? So twisted pair cables shielded twisted pair cables are less prone for the uh, to the noise. If we talk about the applications, twisted pair cables are used in telephone lines to provide voice and data channels. The local loop, the line that connects subscriber to the central telephone office, commonly consists of unshielded twisted pair cables. Okay. The next cable is coaxial cable. So coaxial cable, the frequency, the data rate among this coaxial cable is 100 kilohertz to 500 megahertz. So this is in coaxial cable. This is the arrangement, how this cable looks. There is inner conductor, and after that there is insulator, and after that there is one more conductor, that is known as outer conductor. It is also known as the sealed, and after that there is one more layer of insulators, and after that there is plastic cover. So coaxial cable carries signals of higher frequency ranges than those in the twisted pair cables, in part because the two media are constructed quite differently. One is inner conductor and another is outer conductor. Okay, so instead of having two wires, coaxial cable has a central core conductor of solid wire enclosed in an insulating sheet, which is in turn encased in an outer conductor of metal foil, as it is shown in the diagram, or a combination of the two. The outer metallic wrapping serves both as a shield against noise and as the second conductor. The purpose of adding this second conductor is for the completion of the circuit. The outer conductor is also enclosed in an insulating sheath, and the whole cable is protected by a plastic cover. So there are different categories of coaxial cables. There is one category RG59, and the impedance of this RG59 is 75 ohm. The use of this coaxial cable RG59 is the cable in cable TV networks. Another category is RG58, radio government 58, and the impedance is 50 ohm, and this is used in the thin Ethernet. And third category is radio governments 11. The impedance is 50 ohm, same as RG58, and this is used in the thick Ethernet. What are the connectors used in the coaxial cable? In the coaxial cable, the connectors are used is known as BNC connector. BNC connector. The full form of BNC connector is Bay One Neil Concealment connector. There is also BNC T connector and the BNC terminator also. So these are the connectors. As we did with twisted pair cables, we can measure the performance of a coaxial cable. The attenuation is much higher in coaxial cables than the twisted pair cables. What do you mean by attenuation? Attenuation means the loss of energy. What is the loss of energy? Okay, so Where it is used, what are the applications? So coaxial cables was widely used in analog telephone networks, where a single coaxial network could carry 10,000 voice signals. Later it was used in a digital telephone networks, where a single coaxial cable could carry digital data up to 600 megabits per second. However, coaxial cable in telephone networks has largely been replaced today with fiber optic cable. Okay. Now the next category of this guided media is optical fiber optic cable. But before understanding the structure of that cable, we have to understand the some light concepts, refraction. So this is, here it is shown that the less dense medium air and more dense medium water or glass, if any beam is incident at this angle I, it is refracted at the angle R. So in the first diagram, in the left diagram, it is shown that from less dense to more dense medium, if the ray is incident, what will happen? In the second part, if it from more dense to less dense medium, what will happen? What will be the angle? Okay. Now this is the now this is the critical angle. There are four situations: air and more dense medium to air. There are different incident angles and how it is refracted. So in fourth one, it is shown that this is the critical angle. So in this situation, the ray is on the axis X. Okay. So now reflection. In reflection, this is different from the refraction. One ray is incident. This is angle of incidence, and in the right side, this is the angle of reflection. So this is the reflection situation of the ray. There are different modes: multi-mode, single mode. The mode is divided into two categories: multi-mode and single mode. And further, multi-mode is divided into two categories: step index and the graded index. So what is this multi-mode? So what is this mode? These are the propagating modes. So current technology support two modes, multi-mode and single mode, for propagating light along optical channels. So in optical fiber cables, there are optical channels. So for that, there are two types of modes are used for propagation of lights. Each requires fiber with different physical characteristics. Multi-mode can be implemented in two forms: step index or graded index. So what is multi-mode? Multi-mode is so named because multiple beams from a light source. This is the diagram of multi-mode step index. In multi-mode, multiple beams from a light source move through the core in different paths. Here these lights, multiple beams are shown in the red line, and core is shown in the blue color. So it is shown how the rays are incident and how it will reflect in the core. How these beams move within the cable depends on the structure of the core, as shown in this diagram. So in multimode step index fiber, the density of the core remains constant from the center to the edges. A beam of light moves through this constant density in a straight line until it reaches the interface of the core and the cladding. At the interface, there is an abrupt change due to lower density. So this alerts the angle of the beam's motion. The term step index refers the suddenness of this change. So this contributes to the distortion of the signal as it passes through the fiber. So this is source and this is destination, and core is covered by cladding, some material. This is multi-mode graded index. This is single mode. In this single mode, it uses step index fiber and highly focused source of light that limits beam to a small range of angles. A small range of angles means all these beams are close to the horizontal. So single mode fiber itself is manufactured with a much smaller diameter than that of multi-mode fiber and with substantial lower density or index of refraction. So decrease in density results in a critical angle that is close enough to 90 degree to make the propagation of beams almost horizontal. So in this case, propagation of different beams is almost identical and there is no delay, means delays are negligible. Now all the beams arrive at the destination together and can be recombined with little distortion to the signal. Okay. So this is the fiber construction, how the fiber is constructed. There is some core and that core is covered by cladding, and after that it is covered by buffer, and there is outer jagged. This is the cross sectional view in the right side. It is shown. Now, so if we talk about the connectors of the fiber optic cable, here it is not written. There are two types of connectors in fiber optic cables used. First one is the subscriber channel SC connector. What is this SC connector? It is used for cable TV. It uses a push-pull locking system. And another fiber optic cable connector is a straight tip connector, and that is used for connecting cable to networking devices. It uses a bayonet locking system and is more reliable than subscriber channel connector. If we talk about the performance, attenuation is flatter than in the case of twisted pair cables and coaxial cable. So loss of energy is very much reduced in the optical fiber cable. The performance is such that we need fewer, actually 10 times less repeaters when we use fiber optic cables. Less repeaters are required in the fiber optic cables. What are the applications where it is used? So fiber optic cable is often found in the backbone networks because its wide bandwidth is cost effective. Today, with wavelength division multiplexing, there are so many multiplexing techniques: time division multiplexing, frequency division, wavelength division multiplexing. So when we talk about wavelength division multiplexing, we can transfer data at a rate of 1600 gigabits per second. Some cable TV companies use a combination of optical fiber and coaxial cables for creating a hybrid network. So optical fiber provides the backbone structure, while coaxial cable provides the connection to the user premises. So this is a cost-effective configuration, since the narrow bandwidth requirements at the user end does not justify the use of optical fibers. What are the advantages and disadvantages of optical fibers? Higher bandwidth. The bandwidth is very high in the optical fiber cables. Loss of energy is very much reduced. So, or we can say that less signal attenuation is there in the optical fiber cables. There is immunity to electromagnetic interferences. So electromagnetic noise cannot affect fiber optic cables. Next advantage is resistance to corrosive materials. So glass is used, and glass is more resistant to corrosive materials than copper. Light weighted. So optical fiber cables are much lighter than copper cables. Greater immunity to tapping. Tapping means when we connect any cable to another cable. So the point of contact, point of connection where the both cables are connected is known as tapping. So there are some disadvantages also of optical fiber cables. Installation and maintenance is difficult. Light propagation is unidirectional, not bidirectional. And the cost. The cable and the interfaces are relatively more expensive than those of guided media. So if the demand for bandwidth is not high, often the use of optical fiber cannot be justified. So this is all about the guided media, which is the part of the transmission medium. Thank you.